Hey y'all, today we're going to talk about composite figures. Alright, so what that means is we're going to have figures made up of a bunch of other shapes. So you might have like a semicircle and a trapezoid, or a triangle and a rectangle, or maybe you'll have like this guy, maybe you'll have like something taken out of a figure. So, or this guy has a square removed from a circle. So composite figures, that's what they look like. We're going to find the area of those things, and there's no new formulas. We're just going to use all the old formulas from the last two sections. So here we go. All right, on this first one, I see a couple different figures. Up top, let's fix that. There we go. Up top, I've got this semicircle. So I know that the area of a circle is pi r squared, but since it's a semicircle, which means half of a circle, let's take that area and divide it by 2. So to do the area of that semicircle, I need the radius. So I'm not given the radius, I'm given the diameter. So if the diameter is 20, then my radius will be half of that. So diameter equals 20. That means my radius is going to equal 10 millimeters. Nice. So let's follow our area formula. Pi times 10 squared over 2. 10 squared is 100. So I have 100 pi's over 2. And 100 divided by 2. 50 pi. Units is millimeters and area, so let's square it. So the area of that semicircle is 50 pi millimeters squared. I'm going to leave my answer there in terms of pi. Now, so that semicircle is taken care of. Now I have this trapezoid down here. And in this trapezoid, I have to, let's look at the formula, I guess. The formula for a trapezoid, 1/2 times the height times the bases added together. So I know that a trapezoid has 2 bases, and I know that they're parallel to each other. So I see these 2 parallel sides. We'll call those the bases. All right? So base 1 will be 20 and base 2 will be 32. That means this guy that runs perpendicular to those must be the height, because the height is always perpendicular to your bases. So let's plug in all the stuff that we know now. We know that the height is 14, and that the base 1 is 20, and that the base 2 is 32. Punch that into your calculators and see what you get. Remember, order of operations, so you need to do 20 plus 32 first. And my calculator tells me that that's 364. It's area, so it's millimeters squared. So my composite figure was made up of adding a semicircle and a trapezoid. So I need to add those two areas together. The area of our composite is equal to the area of our semicircle plus the area of our trapezoid. Semicircle was 50 pi. Trapezoid was 364. So our total area is 50 pi plus 364. And if we're going to leave it in terms of pi, that's a fine answer, millimeters squared. Alrighty, in this composite, I'm going to split it up to look at this rectangle. And since it's a rectangle, I know that it's base times height. And this triangle. And the triangle is what, 1/2 base times height. Now my composite looks like I'm adding those two shapes together. So whenever I do all my work, at the very end, I'll take the area of my rectangle and add the area of my triangle. So first, let's find the area of our rectangle. The area of the rectangle is base times height. So let's look at our base and our height. Our base will be this length, which is 37.5. And our height has to run perpendicular to that. So it looks like our height is going to be that 22.5. So the area of our rectangle is going to be 843.75. And the units is meters, area, so meters squared. Cool. So we have the area of our rectangle. Now let's find the area of our triangle. Well, it must be a right triangle because it butts up against that rectangle. And I know that if this piece is 75 meters, and this chunk right here is 37.5 meters, then the base of my triangle must be the difference of those two. I know you can't see the yellow, I'll use purple. So this length must be 75 minus 37.5, which is 37.5. Cool. So that piece right there, that yellow piece, is 37.5 meters long. So I know my base. Now I need to figure out my height. Now, unfortunately, I don't have any cool little tricks there that I can do to find my height, but I do know it's a right triangle. And I'm given one leg and the hypotenuse, so I can use Pythagorean theorem. Cool. And since the 62.5 is across from the right angle, that'll have to be my C. I can call this 37.5B, and we'll call this length A. Or yeah, we'll call it A. That sounds good. All right, so let's see. I've got A squared plus 37.5 squared is 1406.25 equals 62.5 squared. 3906. I gotta solve it for A, so let's subtract. Both sides of the equal sign, right? Sorry, I got a little crammed in that corner there. And A squared is going to equal 2,500. Ooh, that's going to come out so nice. Square root both sides, and A equals 50. Cool, that worked out really nice. So after doing Pythagorean theorem, I know that A equals 50 meters. And that's the height of my triangle. So 1/2, my base was 37.5, and my height is 50. So the area of my triangle after multiplying all those numbers together, I get 937.5. Cool. So now I know that to find the area of my composite, I'll just add those two areas together. My rectangle and my triangle. And my calculator tells me that's the answer. The units would be meters squared. Sometimes with a composite figure, you'll have to subtract an area from another area. In this example, we're going to have a semicircle subtracted out of this triangle. So let's say that the area of our composite is going to be equal to the area of our triangle minus the area of our semicircle. That's supposed to look like a semicircle. That looks a little bit better. So let's start with the area of the triangle. Area of the triangle is found by doing 1/2 base times height. All right, remember the bases and the heights run perpendicular to each other. So if 18 is my base, that means 26, because it's perpendicular to the 18, it must be my height. So that means my area of my triangle is going to be 234. It's going to be feet squared. Cool. Up next, I have my semicircle. My semicircle would be pi r squared, and since it's a semi, let's divide it by 2. Now it says that the diameter is 9 feet. So if the diameter equals 9, that means my radius has to equal half of that. So you can put 9 over 2, or you can put 4.5. I'm going to do 4.5. So my area equals pi times 4.5 squared all over 2. So let's punch that into my calculator. And I get 20.25 when I square 4.5 pi over 2. And if I want that as a decimal, let's go with 10.125 pi, and it's area, so it's going to be square feet. All right, so I got the area of my triangle, the area of my semicircle, and my composition is going to be the difference of those two, so subtracting the semicircle from the triangle. The triangle was 234 square feet. Semicircle was 10.125 pi. And I could leave my answer like that. And that works just fine. Or I can multiply by pi down here and get a real decimal answer. But that is good enough for me. All right, guys. That's it.